So now that we've finished with substitution and eliminations, we should at least contemplate what are the ways you decide between substitution reactions and elimination reactions. And there's lots of ways of organizing this. My personal preference is a flowchart, and I would say that the way you should organize your flowchart is based around these key questions. And in shorthand form, the questions include, do you have a nucleophile at all? Because if you have no nucleophile, then you're probably not doing substitution or elimination chemistry. If you have a base, then that tends to bias you toward elimination chemistry, and specifically E2 type eliminations. Do you have a leaving group? If your substrate does not contain a leaving group, you're not doing substitution or elimination chemistry. If you have a relatively bad leaving group, nothing will happen unless you can make it into a better leaving group, in which case something might happen. But if you're taking a bad leaving group and making it into a better one, you probably have acid present, which means that SN1 and E1 are on the table. Degree of substitution is a great way of organizing things. In fact, the chart that I'm about to fill out here is Pelkey's way of organizing this, and he's basically saying, okay, if there are certain degrees of substitution, that really limits the possible reactions. So that's not a bad way of clarifying things either. My advice, though, is to generate your own flowchart, walking your way through all of this, trying to figure out what makes sense for you to think about. One last thing I really should point out here is that the degree of substitution is a really important question, but it's really easy for you to forget about resonance, and in particular to look at a primary system with resonance and to forget that that's really a secondary in terms of cation stability. So a primary system with resonance is actually going to be SN1 capable, even though a primary without resonance can't do SN1 type chemistry. Underlying all of this, of course, is a question about solvent. Depending on what solvent you have, you're biased more toward substitution versus, say, elimination. But basically, he has a chart where he walks through, okay, if you have a primary, what's possible? And so, of course, if you have a primary, you can do substitution type chemistry, and you can also do elimination type chemistry, but only substitution chemistry of the SN2 variety and only of the E2 variety. If you have a primary, the cations are not going to be possible. So I'm going to use a green check mark to show that substitution chemistry and E2 elimination chemistry are both possible with a primary substrate. Meanwhile, it is not possible to do an SN1 type reaction or an E1 type reaction, except again, if you have resonance. If you have resonance, then of course, these are back on the table because you can form a cation. Okay, if you have a secondary system, then I'm sorry to say, absolutely all the options are on the table. The only question is, which ones are going to be fastest? So the more hindered the system, the slower the SN2 is going to be. The more basic your nucleophile, the more you have a strong base, the more E2 is going to happen. If you don't have a good base, then substitution of the SN1 variety or E1 possibly creep in, depending on how good the solvent is, and so on and so forth. So basically, the annoying category to think about is secondary. With a secondary system, absolutely everything's on the table. You need to think about it all. If you have a tertiary system, then SN1 chemistry is definitely likely. E1 is possible. E2 actually becomes a really, really fast reaction with a tertiary system and any kind of base present. This is the one that tends to trip people up. With a tertiary, E2 elimination becomes fast because you have a base. SN2 is not possible, but E2 becomes really, really fast. So you need to contemplate E2 with a tertiary for sure. What you don't need to contemplate at all, ever, is substitution chemistry of the SN2 variety with a tertiary. Okay, then we have the solvent considerations, and of course, protic solvents tend to bias you toward carbocations, which is to say SN1 and E1 type chemistry, but you want your solvent to be aprotic if you are doing SN2 type chemistry or E2 elimination. Although, I will warn you here that E2 elimination chemistry doesn't particularly care about the solvent very much. What matters more is the quality of the base. And in particular, you can do E2 eliminations with aprotic solvents, but one of the things that biases you toward E2 in the presence of an otherwise SN2 capable substrate is that SN2 will be sped up by aprotic more than E2 will be, so if you want to force an elimination to take place, maybe a solvent mismatch is the way to think about it. Then the last consideration here is that we have nucleophile slash base. The stronger the base, the more likely an E2 elimination is. In order for an SN2 to take place, you need to have a good nucleophile, but not necessarily a strong base. With an SN1, you actually don't necessarily need a good nucleophile at all. And so I'm going to put solvent ? question mark here. It's okay to have a relatively weak nucleophile. In fact, the solvent acting as a nucleophile. With E1, this is basically last resort. This is, you don't even have a nucleophile like the solvent that wants to interact. Instead, you have a very, very weak system. Again, many times, this will be heating it up so that nothing else really wants to happen. One more thing to think about trying to decide between SN2 and E2 is the size of the nucleophile. So small nucleophiles, small bases, unhindered bases, tend to bias toward SN2, whereas the bigger the base, the more likely this has to go E2. Even though I have generated this chart for you, I would advise you that memorizing this chart is not particularly useful. What is useful is being able to start with a blank sheet of paper in front of you and be able to generate this chart on your own. If you can do that by thinking through the questions as opposed to having memorized what I wrote down, then you're in good shape. So you really want to be thinking about what are the considerations that I need to take into account? What should I be thinking about? What are the questions I need to be answering? Once you have your head wrapped around those questions, then you can fill out this chart, and the chart doesn't have much value anymore. I don't necessarily think in terms of these chart considerations. I'm thinking more in terms of a mental flow chart. I'm asking, all right, do I have a nucleophile or not? What kind of substitution do I have? Do I have resonance? All those factors. What is going to speed up an SN1 reaction versus, say, an SN2 reaction? In the final analysis, what matters and the reason why we have charts like this is because the faster reaction is the one that will happen. These are the considerations you should be thinking about when trying to decide.